Hi everyone, welcome to talk session. Let's continue with few more examples on designing of DFA. In this session we will learn how to design DFA that accept all the strings having even number of A's and even number of B's over sigma A comma B. First try to understand condition from the given question. Question mentioned that string should consist of even number of A's and even number of B's. Both conditions should get satisfied. For example, try to write down the minimum length string from the given condition. If I write single A here, how many A's? 1. It's not even. If I write 2 A's, how many A's? 2. So even number of A's. But in this case, how many B's are there? Number of A's are 2. Number of B's are 0. And there is a AND. As we know, whenever AND is there, both conditions should get satisfied. So this is a valid string as 2 is even and 0 is also even. Number of A's are 2 and number of B's are 0. Similarly, if I write here 2 B's, how many A's there? A's are 0. How many B's are there? 2. So both conditions are satisfied as both are even number. Similarly, if I write here more number of A's like this, 4 A's, satisfy the condition, 4 B's, satisfy the condition. And if I write here epsilon, check, are we satisfying the condition? Epsilon means empty string. How many A's? 0. How many B's? 0. Both conditions are satisfied as 0 is an even number. So epsilon is also valid string in the minimum length string set. If there is a combination of A and B, for example AB, AB, how many A's here? First, second, 2 A's. How many B? 2 B's. So condition is satisfied. Number of A's and B's are even. So what I mean to explain here, all the strings which is going to satisfy both the conditions, those strings are valid strings and should be part of minimum length string set. Here we will divide this question into two parts. One part is for even number of A's and another part is for even number of B's. The first sub question will be for even number of A's. So let's think how we can design DFA for even number of A's, and in the second part for even number of B's. We have also seen one of the questions separately for even number of A's in my previous video that we can repeat here. When I say even number of A's, what are the minimum length string? Epsilon, for example, 0 number of A's, valid. Double A, even number of A's, or I can say 4 A's, even number of A's. If I write single B here, how many A's are here? 0 number of A's, so it's also valid. If I write here double B or triple B, no issue, because all these strings contain 0 number of A's, same as epsilon. So these all are valid strings and are part of the minimum length string. Similarly, if I write the minimum length string for B's, if I say epsilon, how many B's? 0. Double B, how many B's? 2. It's even. I can say 4 B's. It's even. If I write single A, how many B's are here? 0 B's. Same as epsilon. So it's a even number of B's. If I say double A, 0 number of B's. So it's a even one. Same as epsilon. 3 A's. It's okay. What I mean to say here, when I say even number of B's, there is no condition on the A. Multiple A's can come. Similarly here for even number of A's, there is no condition on B's. Multiple B's can come. Now let's start designing DFA for any of this, and we can replicate the same for another sub question. As epsilon is a part of minimum length string, as I explained in my previous videos, whenever epsilon is a part of minimum length string, our starting state becomes final state. So epsilon gets accepted. Next valid string is double A. It means what? First A will be read by the Q0. Single A should not get accepted, so automata will go to the non-final state. Second is A, that should get accepted, so it should go to the final state. So first A, odd number of A, it should go to the non-final. Second A, even number of A's, it should go to the final. So double A gets accepted. First A, second A. If there are 4 A's, then we can write like this. First A, automata reach to Q1. Second A, automata reach to Q0. Third A, automata reach to again Q1. Fourth A, automata reach to Q0. So in the 4 A's, automata is reaching to Q0. Q0 is our final state. So 4 A's are also accepted. Is this automata is deterministic? Not it. We can make it. Deterministic means what? For each input of input symbol sigma, there must be only one transition from Q0 as well as from the Q1. At this moment, there is a one transition for A from Q0 and one transition for A from Q1. But transition of B is missing. In this sub question, condition is on the even number of A's and there is no condition on number of B's. If single B is coming, that is also valid because it contains no A's, it's a valid string. If double B's are coming, there is no A, it's also valid string. If 3 B's, it is also valid string. And even though if no B is coming, no B means what? Epsilon. Epsilon is an empty string, it does not contain any symbol, so this is also valid string. By writing this, what I mean to indicate here, if there are many more B's are coming, that is also fine. If 1B, 2B, 3B coming, that is also fine. We do not have any issue because it's a valid string. If no B is coming, means epsilon, 0 B's are coming, that is also fine. So this is a condition of, or this is a scenario of 0 or many B's. And I explained in my all previous videos, whenever scenario of 0 or many B's, you can simply give the self loop at corresponding state for that symbol. Here symbol is B. In this case for Q0 and Q1, simply self loop for symbol B. And this is the final answer for even number of A's for this sub question. Similarly, if I want to design for even number of B's, you can replicate the same answer here also. As epsilon is there, starting state becomes final state. So this is Q0 becomes final state. Double B should get accepted. So for single B, it should not get accepted. So Q1 is a non-final. Second B should get accepted. So it should reach out to the final state. So double B gets accepted. First B and second B. As there is no condition for number of A's, 1A, it's a valid because number of B's are 0. It's accepted. 2A's, it's a valid string because number of B's are 0. Same for 3A's or 4A's. Even though A's are not coming, means what? Epsilon. It's also valid because number of B's are 0 here. Again there is a scenario for 0 or many A's. As I explained previously, whenever there is a situation of 0 or many, maybe for B's, maybe for A, or maybe for any other symbol, simply give the self loop for that specific symbol. So this is self loop for A and here is the self loop for A. So this is the answer for another sub question, even number of B's. But our question is we want this combine, even number of A's and even number of B's. How we can combine this? So let's learn how to combine these two questions. In this case, to combine these two sub questions, I will do minor change in the solution of second sub question. That is nothing but regarding the name change. Here name of the state is Q0. I will change it to the Q2. Why so? Because I want to combine this. And why Q2 only? Here nomenclature is Q0 and Q1. So next will be Q2 and next will be Q3. I explained regarding the name of the states in my basic video of structure of automata. You can give any name to the any state. So this will not change your answer. So I have just changed Q0 to Q2 and another is Q3. This will help us to merge the solution of these two sub questions to find out the solution to our first question. So I have written same sub problem solution here. This is for even number of A's and this is for even number of B's. Now we will see how we can combine these two sub problems to find out the solution for our question. In the first sub problem, there are two states, Q0 and Q1. And as I mentioned previously, I have just renamed the states of the solution to another sub problem where state names are Q2 and Q3. So I have written here Q2 and Q3. Now what we need to do? We need to combine this. How we can combine this? Here first state is Q0. This Q0 state can be combined with Q2 as well. It can be combined with Q3. So write down like this, Q0 Q2 and Q0 Q3. So I'm writing here first state of first sub problem and first state of another sub problem. So both the first state I have written here. Check whether both states are starting state. Yes, Q0 is starting, Q2 is also starting. Also, Q0 is final, Q2 is also final. As both states are final, hence I will make Q0 Q2 final. As both states are starting, I will make Q0 Q2 starting state. Another way, as Q0 is combined with Q2, similarly Q0 can be combined with Q3. So write down here Q0 and Q3. Similarly, we can combine state Q1 from the first subproblem with another two states from the another subproblem Q2 and Q3. So Q1 Q2 is one of the state and Q1 Q3 is another state. So write down here Q1 Q2 and here Q1 Q3. So in this way we can merge the states. Now after merging the states, we can write transitions for all these states. How to write a transition? Write down the name of the states in this way. Q0 Q2, this is our first state, starting state as well final state, and we need to find out transition between Q0 Q2 and Q0 Q3. So write down both states like this. At initial level, once you practice, you can write it down orally also. This is one state Q0 Q2, this is another state Q0 Q3. Now find out what's the transition between Q0 to Q0. There is a self loop of B. Write down this one. What's the transition between Q2 to Q3? Q2 to Q3 transition is for B. So if you observe this state is combined, this state is also combined, still both states having the similar kind of transition, that is for B. So I can write transition for B. Similarly, if you find in reverse way, Q2 to Q3 is B, but Q3 to Q2, this is also B. Q3 to Q2, this is also B. And another way, Q0 Q0 self loop, that is also B. Let's take one more for another state. How to find transition between this combined merge states. Take Q1 Q2 and Q1 Q3. Q1 Q2, write it, and Q1 Q3. What's the transition between Q1 and Q1? See, there is a self loop for B. What's the transition between Q2 to Q3? Q2 to Q3, there is a transition for B. So Q1 Q2 to Q1 Q3, transition for B. If you find out for Q3 to Q2, because Q1 Q1 is having self loop, it will be same. But Q3 to Q2, what's the transition? Again it is for B. So same transition, it will be for B. To find out transition between another two states, similarly write it Q0 Q2, this one, and Q1 Q2. Now you will be able to understand, it's very simple. Q0 to Q1, what's the transition? It's a transition for A. Q2 to Q2, what's the transition? It's a self loop for A. So there will be transition for A. Similarly, if you find out Q1 to Q0, it's a transition for A. So there will be transition for A. And here you can write it down now orally. It's very simple. Q0 to Q1, what's the transition? It's for A. So write it here A. And Q3 to Q3, it's a self loop, that is also for A. Either way, if we take it, it will be automatically taken for another state. You need not to worry about it. Okay. So Q0 to Q1, there is a transition for A, and same with the Q3 having self loop for A. So either way you can take it. No need to worry about it. It will be correct one. So in this way, you can find out DFA for the main question using the sub problems. If you want to verify whether it's deterministic or not, you can verify it. The first state Q0 Q3, transition for A, transition for B. From this Q0 Q3, transition for A as well as for B. From this state, transition for A as well as for B. Same from here, transition for A and transition for B. If you want to verify whether this is working fine or not, let's check whether epsilon is getting accepted or not. Epsilon means what? Empty string. So without giving any input, automata is going into final state. So epsilon is accepted. Second string is double A. Check whether double A is accepted or not. Automata starting with the starting state Q0 Q2. First symbol is A. So Q0 Q2 reading A, and going to the another state Q1 Q2. For second A, there is a transition from Q1 to Q2, from Q1 Q2 to Q0 Q2. So both A's are accepted because automata is in the final state. If we check for double B, automata starts with Q0 Q2 as a starting state, first B reaching to state Q0 Q3. For second B, it's coming back to final state Q0 Q2. So double B is also accepted. If you want to verify for some other typical string like AB, you can verify that. First symbol is A. Automata is starting with the state Q0 Q2. Reading the first symbol A. Automata in the state Q1 Q2. Second symbol is B. Automata is in the state Q1 Q3. Third symbol is A. Automata is in the state Q0 Q3. Then fourth and last symbol is B. Automata is in the state Q0 Q2, that is final state, hence AB is also accepted. So this is the simplest way to design DFA for multiple conditions. You can design DFA for subproblem even number of A's, even number of B's, and you can combine this in this simple way. If you want to modify the name of the states, even it's not required, you can modify like this. You can give name to this state as A, B, C and D. And you can keep the transition labels and transitions as it is, its correct one. You can practice similar kind of example like odd number of A's and odd number of B's. You can design one subproblem for odd number of A's and another one for odd number of B's, and you can combine it, merge it the way I explain you in this example. In the next session we will learn how we can design DFA for odd number of A's and even number of B's. It will be one of the practice session, same what we explained you just now. Thank you for watching.